mentioned in the last video that language has been one of the two main features that have been taken to distinguish humans from all other animals, reason being the other one. So, obvious questions arise as to where language comes from. When did it first enter the picture historically? Is there such a thing as an intermediate step to language, for example? There have been lots and lots of people asking these kinds of questions. We're very curious. It would be nice to know when language, or something we might recognize as language, enters the evolutionary picture. Unfortunately, the evidence is very hard to come by. Language, you see, doesn't leave fossils. Language is ephemeral, at least until the invention of writing. Language is sounds produced and they vanish as quickly as they are produced. So the best we might hope for is the kind of circumstantial evidence that you find, for example, through finding burial grounds, fire pits, bone flutes, needles, beads, items which suggest the cooperation of people who have what we begin to recognize as culture. Now, in the 19th century, there are very many theories floating around about the origin of language, some of them quite crazy. One popular crazy one that's often been explored is the idea that there is this, of all the languages of the world, one of them is the original language. You may have heard that about Hebrew, for example, although several languages have been suggested in this regard. It's unfortunately nonsense. But there's enough nonsense to go around, so much so that in 1866, the French Academy of Science, who are very French, they like to regulate things, possibly they can't be regulated, they banned theories about the evolution of language, which is kind of odd, given that it's a good question, where did language come from? They banned it because it was difficult to see how anyone could make a substantial argument based on evidence that could speak to this question. In order for science to work, we have to be able to tell the difference between plausible and implausible stories. That helps us to arrive at consensus. And if there's no empirical evidence, then there's no real way to sort out the plausible from the implausible stories. Anyway, they tried in 1866 and they failed. It's like trying to keep the tide in by fiat. You can't do it. People carry on coming up with theories in this area. And also, they were perhaps unnecessarily restrictive because, while we can't say a lot, we can say a lot more than nothing. One kind of way we can approach this is we can say, well, which bits of the body, both anatomically and physiologically, which bits have to be in place for language to work? It's interesting that there's no organ for language. So we have a heart for pumping blood, but we don't have a language organ. Everything that's involved in producing speech, the lungs, the voice box, the tongue, the mouth, the jaw, the lips, it's all there anyway. It's all there whether you have language or not, and it serves perfectly fine and prior purposes. So that's the kind of question we can ask, and a lot of interest has been generated by noting, for example, that in modern humans, the voice box is considerably lower than it is in our nearest neighbors, the chimpanzee and the bonobo. And that might affect the kind of way that sound production happens. You can ask, and people have asked, whether the brain treats speech sounds differently from other sounds, or whether they're processed just the same as any other sound. So is any innovation required in sound, in hearing? Another approach that's been quite fruitful is with modern computers, we can run simulations of agents who pass messages, and we can write little code, little algorithms that evolve patterns of message exchange among agents under certain conditions. So we can simulate. That wasn't available in France in the 19th century, but we can run simulations of simple communicating agents in order to see what's plausible and what's not plausible. But all of these are kind of weak sauce. None of them provides us with a strong hold on to answer our question of where language came from. And as a thoroughly modern person, you're probably already thinking, hey, we got to have a genetic answer here, right? Again, in the middle of the 19th century, they didn't have genetics in their conceptual armory. So it seems natural to ask that if language is a characteristic of our species and a very important one, then there might be a genetic story to tell. Now, genes are not that easy to understand. If we could find a gene that we have and that our nearest neighbours, the apes, don't have, then we might look to see is that gene somehow implicated in developing whatever we need in order to speak. But genes don't really work that way. They're not simple things. First of all, our genes are almost the same as a chimpanzee's genes or a bonobo's genes. Very difficult to find any plausible difference that might account for something as huge as language. But it's also the case that genes don't provide simple answers. Genetics is fairly recent science. It only emerged in the 20th century. And our ideas of what genes are constantly changing. Genes used to be seen, maybe 30, 40 years ago, as little blueprints for the developing organism, specifying what way it should develop, whether it should have red hair or big fangs or a tail. But that's not the way we view genes these days. Genes are involved in the development of an organism, but they don't specify the form of the organism. But we don't have time in this course to do any kind of full treatment of this, but you should know that genetic stories are not simple stories, and nobody these days is going to be convinced by a suggestion that this gene is responsible for language. That's just not going to happen. But there is a slightly longer answer which is worth looking at here. Back in the 1990s, at the time when genes were still understood in a more simple manner, and they were used to provide answers to complex questions in a way that we wouldn't do today, there was a family identified in England known in the literature as the KE family. And over 3 generations, many, but not all the members of this family had a rather rare language problem. It has a name, developmental verbal dyspraxia. That name is a bit imprecise, but certainly there was something wrong, and there was clearly an underlying genetic cause for this. So the pattern of inheritance perfectly matched that was familiar from genetics. And so there was a single gene at fault, and in fact they had a variant of a gene which had the funny name of FOXP2. Genes have funny names. It's an interesting gene. It's found in all mammals, and there's slight differences as you go from species to species. So you find it in dogs and bats and monkeys and so on. Even between humans and chimpanzees, there's slight differences in this gene. And there was a mutation on this in the family, and so we have a good reason to believe that the problems encountered in this family were due to this mutation. But their problems were not restricted to language. They didn't include all of language, and they included other things than language. So there were cognitive deficits, learning problems, for example. They had general social problems. They did speak late, and they had difficulty pronouncing their speech clearly, but it wasn't a gene that selectively targeted something we might call language. And we know a bit about FOXP2. We have good reason to be interested in this gene. In many species we've studied, we know that this gene is important for the healthy co-development of the brain and the lungs together. Now, those are body parts that are very, very relevant in speaking, and so any modification to the relationship between the brain and the lungs will have spillover effects for speaking, but that is not to pick out language, unfortunately. So there was severe problems with how science is communicated. Because there's a great appetite for answers to questions raised in this kind of domain, journalists were falling over themselves to announce prematurely that the gene for language had been found. There were reports published both in journals, scientific journals, and above all in the popular press that announced that we had found the gene for language, the Holy Grail. We hadn't, no such gene existed, but it took a couple more years of sober research and careful thought to make it clear that the gene for language had absolutely not been found. It is possible to form a view for yourself of this, so I found a video on YouTube in which one member of this family, of the KE family, presents himself. And I'd like to show it to you because it's interesting, first of all, to meet the face behind a story like this. And I'd like you to reassure yourself that, one, this character has language, and two, that while he has challenges, as he'll be quite explicit, they are not all, and certainly not primarily, problems with language. And of course, he's a wonderful person, so let's have a look at him.
Hello people, today I'm going to talk about 5 things about me. 5 things about me. Let me think. Number 1, I have a rare speech disorder called Fox PH2. If you want to know more information about that, you can. Go to Google on the KE family. I'm famous in the medical history on that. Number 2, I have a learning disability, but I can learn how to sort good things out from that. Number 3, when I was born, I learned sign language. Patrick Gorman, then I changed to Macintyre, then I changed to British Sign Language. And from that, when I was young, I was non-verbal, so now I have achieved a lot in that. Number 4, I love helping people in different ways, especially hearing or deaf in the deaf community. I've got a good passion and love about that.
I'm going to stop him right there. You can see this guy clearly has language. He also has some difficulty in pronouncing his words. That he has language is also evidenced in the fact that he learned 3 different sign languages. And you can clearly see this is not simply a person minus language. Now, this poor reporting is something we'll meet again and again in this module, because the public are often presented stories by journalists that feed into the imagination and that are not well grounded in the science. That slide should say it's 2022, but 4 years ago we saw a drastic illustration of this. There's a scientist who's on Twitter saying Twitter is debating if scientists should ask to check quotes in media reports. He says, a while ago, interviewed for a popular Sunday magazine, I said, there's no such thing as a language gene. I hate that term. No single gene can determine a person's language ability. And what did they print? We discovered a language gene called FOXP2. Chimps have it, but with differences, which is why they'll never be able to talk. And this is attributed to that professor who said, there is no language gene. I hate that term. So when a question captures the popular imagination as a genetic answer to the question of where language comes from we need to be careful, and we need to make sure that we can sensibly interpret the kind of things that journalists write. Journalists are notorious for simplifying, oversimplifying, and frankly, making an absolute mess of those rather cautious statements that scientists like to make. So much for the evolution of language.